All right. Hello and welcome, guys, to Bug Free Productions. This is the main bug, Isaac here. If you're new to the channel or you just have been finding everything interesting and useful, remember to like, subscribe, comment. Um, Make sure to comment any questions or any ideas or requests you would have for the channel, and then we have this last one, which is very important. Nobody likes a stressed out programmer, so we're just going to chill a little bit. Quick look at our schedule. We have, while everybody filters in, we have where we are at. We're on YouTube on this bug-free channel. Runs Tuesday, Thursday, 6 p.m., and then Saturday at 10 p.m. Saturday is our art stream, where I just needed something to do that wasn't programming. So Saturday's art day. This week we'll be looking at concept UI, concept drawing for UI, wireframing, so on. A little bit of sketching, and concept for how I would approach doing the art for my other, the other stream that I have been doing. Not other stream, but other playlists I've been making streams and videos for, which is for creating a bike racer. Arcade style with physics. Whoops, there we go. So we're at 6:01, we'll probably give that a couple minutes and I'll start opening some programs. While that runs, we have this one, it looks like everything is open. So I'm gonna go ahead and just kind of hit the ground running here. Let's get back to our audio. So I started using Game Chops as some background audio, so if you're interested in that, go ahead and check that out. They're DMCA free music, so you can use, at least from what I've seen, so you can go and use them in your streams as well, or what have you. Those are kind of nice. So let's hit the document first. This one, what we're going to try and do is designed to be a quicker one, so this will be done in 2 or 3 videos, 2 programming videos and 1 possible art stream, depending on how we go. So we got Brick Breaker. So those aren't familiar with Brick Breaker, it's like Pong at the bottom, which I think my cursor's captured. Anyway, your cursor moves left and right, and you try and hit a ping pong ball up into the corner and up against bricks up here that'll break. And then we'll also be scoring those, so different bricks will have different point values, certain things like that. So if we start at the top here, we have our panel moves. According to a mouse input, we're going to use the new input system, which I just realized I didn't actually install yet. So, well, that'll be tomorrow, I guess. We'll start with some ball bouncing. So we make the ball bounce using physics. We limit its velocity. We'll tackle some of the stage design. We'll tackle some of the minimum angle, paddle design. So there was, at least in 2018, a bug where the certain amount of bounce wouldn't push it off of the wall. It would still just fall right next to the wall because it wouldn't necessarily collide with it. And we're just going to take that out, make sure that doesn't happen. Either through our paddle design, which we probably won't do because we're looking at 3D. But I don't remember strike through line. There we go. So we probably won't be shifting our paddle a lot, at least in the coding streams. But we have a minimum angle. This was an idea we might actually do, where we just make sure that our ball doesn't fall at a, say, angle that's, what would it be? If you look at the y-axis, it would be the 180 angle. Just make sure it doesn't fall straight down, that it must be falling left or right in a little bit, so probably like 10 degrees or something left or right, so that the ball never actually is allowed to fall straight down, which is something we could do. And then brick break score rules. So then we have our scoring rules. How do we destroy blocks? How do we create prefabs of blocks? And can we score more successively if we break blocks before the next time we hit the ball with our paddle? Which is easier to do than it sounds. Scorekeeper, singleton, and as a persistent game object. So we will use one pattern in here for sure. That's just kind of unavoidable, being that it's for a scorekeeper. So we're going to have to use this scorekeeper in a singleton pattern that's a persistent object, and then figure out how to reset the base scene note. Reset your score based on the scene number, because we don't want to actually track that. And after we complete a round. So we'll continue on with this, and we'll start one. We'll probably just wait for the mouse input till next video, unless we get really far, and just get these done. So these should be pretty fun, pretty easy also. With that, I'm gonna go make sure this is up, and then we can pull up Unity panel, make sure code is working. Code likes to not work. Not my code, but the code window. For some reason, it just really hates the studio that I use, Visual Studio. OBS just really hates to record it or acknowledge its presence in any meaningful way. And then Unity, which is up here. I use a window capture, which doesn't show the pop-ups. So if I go up to like File here or something, whoops, can I get chat out of the way there? Okay. So if I can get, let's grab Unity on only window panel. And then we have Unity. So if I do something in File, I'll probably just read it out, what the command would be. So say I go File, New Scene, which would create a new scene. So let's go to Assets. And we'll start here. So like for instance, if I say File, New Scene, so File, New Scene, and then you do empty. And run create. This will create a new scene that's untitled. So I'll read through all these ones, and the reason I just don't do a straight screen capture is I tend not to be able to flip through the panels as easily, because panel can't remain up as well as I'd like it to. Or if you go right click in here, so we have our hierarchy, you go right click and create empty. You'll get an empty game object. I'll figure out a better way eventually. I just haven't had time to really practice with flipping through in a different way, and I didn't want to break this one because of that. So we got, I just want to go sample scene. I don't want to save that. Anyway, so Brick Breaker, like I said, also to make it easier because it does screen window capture, I just have all my windows docked here. Yours probably won't be docked by default. you'll have a different layout. What you need to do if I have a window open in here, is you go Window, which is up on the top of your screen. You'll do Window, and then you'll just have to find the certain one, like Package Manager will be in there. So that's where I found Package Manager. And then you can just drag it into the snapping position and drag it out and drag it back in. And that's easy that way. So that should be good. I'm just going to use the sample scene. If you left click your sample scene and then right click your sample scene, you should be able to use the menu option to click rename. And we're just going to rename this. What should we do? Call this start menu. Then we have start menu, so let's you'll see that changed the name of it up here in the hierarchy as well. Go ahead and go Window. If you don't have lighting open, go ahead and go Window, and I believe it's in Rendering, and then Lighting. So Window, Rendering, and Lighting, and you'll get this window. And we want to go to Environment, and I think it was to lower the intensity by like to 0.8. Do about 0.8. And go ahead and delete the directional light. And you'll notice your screen should look something like that once we delete your directional light. Essentially, we're turning the 80, we're only going to use 80% of the light of the, 80% of light from the, from the skybox. So from our selected skybox, we're only using an intensity multiplier of 0.8, so we're using 80% of its normal light that it would generate. Which is important to turn this down, because if you want to do lighting effects later, it'll look terrible, but you can always come back and turn it back up to 1, which will make everything just really rendered and lit. I tend not to, because I like to work with less light on my screen, as well as shadows and emissions are more visible this way when you're testing and whatnot. I notice you turn it down, if you turn it down below 0.7, it gets a little dark for while you're working in it. So I tend to stay about 0.7 and to 0.8 when I'm working on a development one. So start menu, we always need a main camera. This main camera has a, if we go back to the inspector over here, we can inspect an object, select in the hierarchy and go here. Transform camera has a layer of default and a tag of main camera. That's what it was. So if you click the drop down, you can see the different tags that come preloaded with it. We're not going to use any of those tags. Only tag I've ever really used is one for troubleshooting, and then this main camera tag. Layers we'll probably use as we keep going, and then might not even be necessary for this project. But package manager, this is where we would go to get our packages, and that's again in Windows. Windows package manager. Build settings, which is actually in File, Build setting, and project settings, which is in Edit project settings towards the bottom of your pop-up window. On the pop-up window, so you'll notice we have a few things here. We won't be messing much with this, but it'll be nice to know it's there. If you're doing a company name, you might want to put your name in here or something. And product name, so Brick Breaker. You can always change this. The one thing that note is you should change this right away, because this affects your um, temporary file structure that it generates. And before you start changing things in serialized fields and whatnot, you'll want that changed. But enough about that for right now. What we're going to do right away is we're going to make a canvas. So if you click here in your hierarchy and you right click in your hierarchy, there will be a pop-up window that opens up about here, and you just want to go UI canvas. And what do we have here? We have, so we have a new object here. We have canvas, canvas scaler, and graphic raycaster. I don't know why this resets, because there's an error, or not an error, but it warns when it resets. One thing is to switch it here. It doesn't look like there's an error yet, so that's fine. Event system. Okay, it's when the canvas type changes. So an error will appear when we choose a canvas scaler. So I'm going to go scale with screen size, and I'm going to give it a reference resolution of 1080 by, no, 1920 by 1080. And what this is going to do for me is it's going to allow me to go ahead and, there we go, 1920 by 1080, and it matches the width or height for me. Reference pixel, 100 pixels per unit. I'd get into more of that later if we were dealing with some different camera tricks, but for right now 100's fine. So then we have camera, display, vertex color, gamma color, space, yes. And that all looks good. Event system still says this is fine. Must be the input system. So this one works with the old input system. And because I haven't switched that over yet, it's not showing me the errors that I had in my other project. Namely the additional shader channels. Yes. Which is fine. It's not a big deal. It wouldn't be a big deal anyway, even if we had those warnings. So with the canvas, we have the canvas scaler and the graphic raycaster. This basically picking up when we raycast, so when we click on our canvas. Next thing I want to do is I want to right click on our canvas. So you click on it, right click, and then you go back down to UI and you go, we'll need a panel. Fun thing about panels is they block all raycast through to the bottom layers, so anything below it is not going to be visible. I just go ahead and I turn mine all the way up. So if you click on this panel, then there's a little pop-up where it shows you how to change, or shows you to change the color and anything you want to do in there. You can make it green. I'm going to stay with bright white just for now for testing purposes. You could also add a material to it, which I don't want to do right now anyway. And then from panel, we can go to the same UI and we go Text Mesh Pro button. Do we want a button or a text? Let's do the button. And this is what it brought up as a pop-up when I clicked on the button. Since I don't have it imported to this project, I just need to go ahead and import it. And then I can go ahead and close this because I won't use it again. If it Oh, come on, Unity. Okay. This is an empty method. It doesn't do anything yet. Unity has the nice, well, if I knew I would have had to relaunch the project, I could have installed the input manager system. Okay. Unity crashes. What can we do here? So while we're waiting for that to boot back up, looking at this code, let's shift over to here and let's right click. So double click, select, right click, and I'm going to go rename. Oh, that's interesting. I didn't think it included that pop-up window. Anyway, we'll go ahead and we'll do some text. So what do we want to name it? Let's call this the game manager. Alright, and Unity finally opened back up. So I hit enter, and my rename function takes care of renaming it across wherever it needs to be renamed. That means anything referencing this would also get that reference updated, and that's a Visual Studio specific function there. Let me go and take you back to the Unity one. Okay, so Unity here, I am just going to go ahead and install the input manager because we'll work in this code over there for a little while, since it's already decided that. So let's go ahead and go to the package manager. And it's compiling because I was in a different window. Working on the code, add to recompile. Okay, so here let's go input system. So there's packages in project, which is really irritating that it always selects that. What you need to do is you need to go to the Unity registry, search for input, and should come up input system 1.7 must be the latest one. So we're going to go ahead and install. And what am I using for Unity version? I'm using 2022.3.38F1. It's 2022.3.38F1. It was the latest Unity version LTS when I started this streaming. So that's what we're using. And I'm still using hub version, what is it, 3.5.1. And that's just because I have JavaScript dependencies that I can't change that out for just yet. Using a new input system. And then we hit yes, and it'll close our project and reopen it. So let's switch over to code while that figures out what it's doing. So we got game manager, we got mono behavior. So mono behavior basically means he's going to go on a game object, must exist on an object. Also means we can't use a constructor with it. Unity doesn't like you using constructors with those. So the way I usually lay out my code is I go vars, method, and accessors. So industry standard in a lot of places is variables first, methods second, and then you would probably have what I call accessors up here, which would be your gets less gets and sets. And then I think constructors was like down here or something. I don't remember. It's been a while since I had to use constructors. Especially, yeah, constructors. Or just a while since I was in that particular industry. I've worked mostly as freelance for a while, so my code ends up being like this because it's easier for me to design in Unity. So I have the accessors instead of gets and sets up here. And then constructors I just don't really use a lot because I end up using a lot of mono behaviors. But constructors I'll still keep right about here, right under methods. And the reason I do that kind of thing is, so if we look at it, vars are what we set or what we are establishing before we start anything. And we have methods which are executable in like on call or on update, which is the same thing. Anytime something gets called, we decide what it does here. So an example of that probably in a different class. Constructors, like I said, we don't use them on a behavior. It's a bad idea. And then accessors, that would be our gets and sets. That's because I don't change an accessor very often, and I want to keep them separate from the variables to help me think of them separately. And I always use variable names in my methods. Some people disagree with that. They think you should use the accessor form, the getter set, but it helps keep things, at least on this page, very one-to-one, and then I don't have to worry about an accessor setting it or something going on here. With a few exceptional cases where I need it to do something specific, but that's generally the format that I have developed to keep things organized for multiple developers and such. Unity just fixed their namespace problem, which as of like 2018 was that sometimes it wouldn't show up in the inspector if you put your class in a namespace. So feel free to use more namespaces now. I think they got more after it because of the way the Unity Asset Store works, because they're expecting you to have all of your code in a namespace when you publish it on the Asset Store. So if it doesn't show up in the inspector, that's kind of a problem if it's required. So they had to, so that's fixed. Just make sure you share with your development team what namespaces you're using and for what, so they know ahead of time and don't just kind of have a access issue later where they don't know what using statements to use or whatnot. So we have variables. What are our game manager variables? So we're actually going to use a static instance. You can just use methods to do this, but I prefer to use a static variable. That simply being that it's not very it's not very nice to look at the way that that works, because it usually only runs in on awake, and that's not very good. That's actually a problem. So we're going to go over a simplified version of what I've seen on some development websites, which were overcomplicated. So we have an instance, and we're going to have an accessor. So this is going to be, and anytime I do a singleton pattern, is the only time I use private, or one of the only times I use private variables. I don't greatly believe in that. One of the reasons is, when I'm developing, I'm usually doing like all the prototyping and stuff. So for somebody to come in and not be able to access any of my private methods and all that, well, that kind of sucks. So I don't use private all that much, and you'll see later how and why that works out the way it does. At least for game design and application design, maybe not so much for certain other things. Methods, so we're not going to touch the methods just yet. So accessor, we're going to have a public static. We're going to have a public static game manager. And then that's going to be get, that's not it, return, and it's going to be that instance. Okay, so we have the instance, get return instance. Can't really type all that well. Static, game manager, get instance. Why is this messing up? Because it's not called anything. Can I call it game manager in here? I don't think I can. Can I? Nope. I'll just call it capital instance. Which that makes sense. Runs into naming collisions because that's too many things named game manager. Essentially. What do we have? Public state game instance. Okay. So we're going to just break these into lines so that you can see a little bit better how this works. Because here we're actually going to do something a little bit different than a standard get. And the reason for that is when we start, this is null, right? Because we've never made this. We've just created an object and this here. Now we could not put anything in here because game manager is a game object. It's mono behavior, which means it can't have a constructor, which means we can't define it in a variable. So, because we can't define it in a variable because there's no constructor, what do we have to do? So, if somebody calls the get this static manager instance, so it'll call game manager and look for the instance, and if instance is equal null, I've written this like 2-3 times now for demo things, different classes, we need instance equal a new game object, which isn't quite right. So the computer's trying its best, but it's just not quite right. Let's try AGO, which is going to be a game object. So AGO is a game object, and that is equal to a new game object, which will create a new game object in the scene parameters for the, even though they don't technically have, they technically still have constructors, but we're just not allowed to make ones for them, is essentially how that goes, because they still have creation parameters. Like if I want to, actually, there's a cool one I learned. So in this parameters, you can put a string, and that string will be what the game object is called. So we'll have a game manager named game manager in our hierarchy, which is kind of fun. And then we have an instance. So our instance is actually going to be the game manager object, not the game object that the game manager is on. So to create that, we need a game object, and then we add the component that is of type game manager. So game object adding component, which is a method in game objects, adding game manager. Cool. So now our instance is correct. Our instance is set. One more thing. So we need AGO. No. We need, is it game object? Game object, no, it's above that even. It's do not destroy unload. So don't destroy unload a game object. So now this won't be destroyed when we change scenes, which is important for our game manager so that he doesn't, dump anything. Then what I would do here, because we're always going to reference by instance, right? That's our goal of this idea. So now we can just treat it like a normal class in this project. So protected, well, we might as well do private because this is a singleton, so we're not going to inherit anything anyway. So private, and then let's go we want integer or float. Let's go float to be safe. We can always round off. Float, and then player score. Player score, and that's going to equal 0 when it's instanced, so yes. So when the game object's created, player score will exist, and it'll be equal to 0. Beautiful. There's a really funny C# bit where certain kinds of floats are accurate and certain kinds of floats are not. Some fractions with base 2 power and positive numbers up to a certain amount are accurate. Positive integer values up to a certain amount. And that was just kind of interesting, considering in Java they're rarely ever dependable. And in this case, it's still not very dependable, but I mean, funny trivia. Don't destroy unload, AGO, return instance. So create, do not destroy it, and then return the instance we made, which is good. So we won't actually be putting this in the scene. This just does everything by itself, and we'll be defining methods here later. Unity finally opened back up, which is a phrase I'm getting too comfortable with saying. And once it reloads, then we'll look at it. Okay, so I'm gonna assign, but it's never used. Why is it? I don't know why that's not supposed to usually come up. If you want to hide your warnings, there's a tab here that has alerts, which this is like your debug statements. This is this error debug statements. And here's your warning debug statements. So I'm just going to turn that off because I don't want to look at it. And I'm not necessarily having troubles or worried about that warning for right now. If more show up there, I might open it and look at it again, but that's fine. Oh, come on, come on, come on. All right. Looks like that's working. Okay. hopefully it continues for the last half. Alright. Start menu. Let's save. Okay, so depending on how much it cut out, all I did was add a panel to the canvas, select right-click UI panel, then on the panel, select right-click UI button, and then button has two parts, as button, as Text Mesh Pro object. So we can look at Text Mesh Pro, and we can add the button, which is the text. So what do we want to do with this one? This one we're just going to go start. We're just going to make a big start button. Big start button, and then we'll go back to button. And I want this about 500 pixels wide by 300 pixels tall. And you notice that start text is really small, so we're going to go back to text. We're going to go to font size under Text Mesh Pro and UI. And it's going to be probably about 45. And since start is a small word, we can go bigger. So we can go 56. That's good enough. And then we can go look at the button. So the button has normal color, highlighted color. And we'll just change some of this to be more expressive and show what's going on. Orange. So change pressed color. Button's fine. We're not going to see anything after this anyway. We're only going to see these first three colors anyway. With the setup we're going to make anyway. So, color multiplier, don't need that. Fade duration, don't need it. So my next one, Z-axis lock. I made that one. I'm also going to go ahead and right-click create C# script. And that script is going to be a object that, or not an object, it's going to be a script that goes on top of the canvas. So let's call it canvas nav. So canvas nav. So we go canvas nav, open the canvas nav, and that'll open it in our IDE. Which it looks like that also broke for some reason. There we go. It came up. It survived. And then I'll flip back over to the code view. So our code here, and then we have what it auto generates for us, or starting our update. Go ahead and get rid of that. And usually I'd go through a few more form things like comments and that, but we're just going to go a little faster with this. Especially with the video crashing all the time. So we got canvas nav, mono behavior. And this guy's going to go on top of the canvas. He needs variables. He's probably going to need accessors, and he's definitely going to need methods. So variables, what would he have? So I'm going to start a new one here. So serialize field. Because canvas nav is going to have, does it have any values? Definitely has methods, because we need methods to change scene. And anytime we change scene, we need to use a using statement up here. So we need using be unity unity engine dot scene management, so that we can access the methods that allow us to change through scenes in Unity. methods are going to be, the only one we'll use is load next scene. And what should we call the other one? So this one's not going to return anything. It's going to need to be public. So it's callable outside in order for the button to work correctly. And that's going to return a void. Because it returns nothing. Takes in an integer. And I actually like, what is it? AIDX is how I like to write it. No certain reason, but I like all of my abbreviations to be capital, and A to just designate it's one that isn't necessarily particular, since it's coming into the method. So we have load scene, and all that's going to go is we're going to go to scene manager. So scene manager, which you'll notice just comes up like that, and we can access the load scene, and we'll just pass that scene index in. Load scene can run either with a index, or it can run with a string reference, but programmers should use indexes. Only in the case that it's very inconvenient for your designers to use should you ever use a string reference. Or in certain cases, like netcode for game objects, I don't think had, or at least didn't have it incorporated at the time I learned it, didn't have the index reference working for multiplayer type stuff. But this is what you should be looking at, indexes. It's easier to get indexes right than it is to get string references right for programming. So let's go load next scene, and then what do we want? We got load start screen is what I'm going to go for. Public void. Load start screen. Just some mistyping. A little bit of parentheses. And what do we want to do when we load a start scene? That's still running, right? Yep, looks fine. So what do we want to do when we load a start scene? That would be scene manager, and instead of taking in an index, we don't need that because start scene is going to be the first scene, right? So we just load scene. And actually, we could use something even less, even dumber. Let's use that method we just made. Whoop, that's not what. Load next scene with index 0. Cool. And that should pretty much work. So how do we test this? We're just going to jump back over to Unity. And in Unity, we're going to go ahead and look at once it compiles. It's got to compile a little bit. So everything's compiled. So where would we want to put this new script that we just made? Well, we want to put it on the top layer object. So over here in your hierarchy, you can consider each one nested underneath its parent. So it's like very much the same as child and parent game objects. Or other child and parent objects, I should say, or game objects. And these guys can just access the children and also access parent. Not going to do that right now, but you can do it. And the best way to do that is anything that multiple or one might access under here, one of these objects might reference, we should put it at the next level up. So we're going to go and add component, and we're just going to look up our canvas nav that we made. Canvas nav, there we go. And yeah, there's nothing in there. Whoops, I need to get rid of that serialized field probably. And then save that file back up. Okay. So now this should be fine. And we're going to get displayed packages. The button. So the button has a field underneath that's its on-click field, which can use publicly invocable events. So we grab our canvas. So I just grab and drag. There's other types of things you can do to get that selection, such as opening this, but this fills up pretty quickly as it'll give us every object in our scene. So drag the canvas over, and then no function. We're going to go through and select canvas nav. So it'll give you a drop-down pop-up window, and it'll canvas nav, and what you want to select is load next scene. We're going to go 1, because 1 will be the next scene in our build index. This will be scene 0. Button. And then there's still one last thing that we have to go do, and that is to have more than one scene. So we need to go back to scenes. We need to create a scene. So you go left click, right click. Create a scene. So create scene. And it's a pretty massive menu. So if you ever have a problem like that where you can't find how to make a scene or something, but you have other instances of that type of thing, you just go left click, Control D, and it'll give you a copy, essentially duplicate it. So let's go to inspector. It doesn't give us anything. So if we right click and rename that, so stage 2 currently isn't a complete copy of stage 1, which is basically a new default scene. So let's open stage. Let's not open stage. Let's build settings. And if you don't have this window open, you go to window build setting, or no, window build settings. You go to file build settings, and that'll open your window and you can dock it. So there's nothing in here right now, so we add our open scene, which is this one. You can also drag a scene in. Then, so let's look at that. So let's open stage 1. And you'll notice that it's a default scene, meaning it has a directional light that I don't like anymore. Build settings. What is it? Package. What was it under? Anyway. Camera, viewbox, MSA. That's fine. Oh, it was lighting that I wanted. 0.8. So 0.8, we got main camera. Alright, so what does this guy need? Well, we could rebuild the canvas. Or we could edit the one we made over in the other scene. So if we go back to Start menu, go to Assets, and then right-click, Create Folder again. And we're going to call this one Prefabs. And then this canvas, I'm just going to drag right in. And I'll create a prefab called Canvas. And one new UI, or at least new to me, is this little arrow. So if you hit that, you can view and edit your prefab this way, rather than having to double click here and go into it, which will still work. It's just easier not to do that, because then you can click here, and then you can click up here, and it'll take you back to scene. And you'll have essentially done the same thing as entering this prefab scene, which is cool. With that, I'm going to save, which I just hit Control S a lot. Materials, prefabs, so we have prefabs. Then we need to go back to scenes and go back to stage 1. It may seem like a lot of jumping around right now, but we're just kind of looking at what we can do. Sometimes it's better to jump around a lot than to try and do everything on one screen. So then I'm going to go Assets, Prefabs, and throw in our canvas. And because I don't really want to change the canvas prefab too much, I'm actually going to select right click and go prefab unpack completely. So unpack, if I click that, you'll see that that unpacked pretty much everything, but on a larger object, it won't unpack the prefabs underneath it. So, but if I hit right click, find prefab, and unpack completely, even the prefabs inside this prefab would be unpacked, hence completely, which can be very useful because, especially when you're doing troubleshooting, like you're trying to learn a new software package or a new asset package, you're going to want to go ahead and just unpack their prefabs and view them and then compare them to yours, or like sub in objects back and forth. Can be more effective than they don't always have the best documentation. So that's just a little hint and tip there. So we're going to look at the panel. We're going to look at the button. What do we want from the button? So we want to change this button. What do we want to change it? So first of all, it's not the start button anymore, right? So let's select the text and let's change the text. Let's just call it next for ease. For ease of function, we'll call it the next button. And from here, what do we want to do? We want our button not to take us to scene 1, we want it to take us to scene 2. Because if you open your build settings, you can see 0 is start scene, scene 1 is 1, and then stage 2 is 2. So we're all in line to keep moving. And from here, what do we want to do? I might close my package manager so I don't look at it all the time. There we go. So we have our panel. That didn't change. Button just loads the next scene. Okay, but we want this to be the game scene, right? So how are we supposed to play the game if our clicks can't go through the screen? Well, we just gotta turn the button off. And we'll have to make something that'll turn that on once the round ends. So now we're actually going to start spawning our round. So laying out the objects and laying out essentially the game board. Before we start laying out the game board, I want to go and take a look at our camera. So our camera here is going to be a little bit different. For the beginning development, and then I'll show you some styling things probably in the art one or what have you. But the camera has a couple different types that you can use: projection, perspective, or orthographic. I'm going to put orthographic on, and then I'm going to create a cube. So create 3D cube. And you just do that, right click, create empty cube. Not create empty. You just right click in hierarchy and select 3D object cube. And with that cube, why is he not rendered very well? Where's he at? You can look at his transform, and he is 200 plus units away from origin. Considering you only get 300 points before it doesn't keep track of you anymore, that's pretty freaking far away. So there's 0, 0. Cool new thing, added in like 2021 or something. We got scalar that locks proportions. So we can go wee. Change the size of our square locked. I'm not going to do that for this particular one because I need the y-axis to be like about 16. Let's start with 16 and see how that's wrong. I meant my x-axis needs to be like 16. So that's 16. Yeah, this is pretty much coming out the way I anticipated that would be. You can change your camera distance, you can change your size. What's 16 on that look like? So we're going to stay with 5. That seems like a good amount of units. Once you get your general stuff down, you can always change it later too. Whoops. Alright, let's change it with this. Let's go -4. Now why is it going up on the y-axis? That's weird. Oh, that's because we're in camera. Let's put it 0. I wanted my cube to be what I was changing. Let's put that at -4. Yep, that's about what I wanted. Could even go more like 5. And then let's up 16, go 18. And whoops. Alright, and then let's go ahead and create some more cubes. 3D cube. One more shortcut: if you hover over transform, right click and do the reset. That's the first option right there. It'll reset everything on your transform. Good if you want no scaling and no position information while you're working with something, which is quite often you'll want that. Let's call this wall. And let's Control D, and this will be, we'll call this the right wall. And we'll move his position over like 16. Maybe 16 is too much. Maybe we want like 8. Maybe like 9. And there is math you can do to map out where on the screen they would appear. I'm not a math person, as anyone can attest. I mostly logic my way out of having to do complex formulas. Not R, this will be L. And then this position X will be -9. Which is about right. And their Y scaling will be 16, sure. Which is actually a little bit wider, but that's fine. Let's go 16. And I might go, I'll try and keep that about there. So then let's do one more. Create 3D cube. And we'll call this top. And this guy is going to get mapped to, let's reset his transform altogether. Let's put him Y units up, which would be 9, right? Is that right? No, that's not right. These were right, and left 9. What was this one? If you click on an object in scene, you can get some information. It should select it. Unless you start layering. Once you get so many layers deep, it's not as simple as just selecting that by clicking on it. Certain objects also aren't clickable, so that's not a good habit to get used to. It's best to get used to going through the hierarchy. But we go 5. That looks about right. You can barely see it probably, but. And then this guy's gonna be, what, 16? Right? And that's on the x-axis. Wasn't it? That's rotation. Wrong field. There's that. And it's not the same. What? 18. I see. So now we have a closed off box. You could adjust this border, you can make it bigger, deeper, affect how, if you rendered materials on here, you can decide if you want a frame or if you don't want a frame. If you don't want a frame, I'm just going to go select cube and select, so click, shift click, and then everything that they have in common will be highlighted here. And if you didn't want it to render, you just go boom. But for visibility purposes, I'll leave it on for right now. And then also, if you were going to do the boxless display, you could either just leave that turned off, or you could remove both these components, mesh filter and mesh render. If you don't try and remove mesh filter first, I think, because mesh render relies on it, so it'll force that to be persistent, I think, to stay on even if you try and remove it. So we got cube, we got wall, all this type of stuff. That's pretty good. Next thing we want to look at is probably getting a ball in here. So let's go ahead and get a ball. So let's right click and go 3D object and go to a sphere. We're just going to use a sphere for right now. If you have an asset you want to use right now, go ahead and pull it in. But for demo purposes, we're just going to use this ball. And to help color in our scene a little bit, we're going to go to Assets and that Materials folder that I made. I'm going to create another folder called Render. And with Render, this is where our render materials are going to go in. Which actually I kind of want to call Render Materials. And a good thing to keep in mind is just to make sure you use this type of casing. Maybe throw in some underscores if it helps break things up for you. just make sure everything's really readable. Try not to do that in classes because the way Unity looks at it, it's going to try and break up the words in the class, and then it's going to be bad because underscores don't count as spaces. I mean, don't count as a changing case. So it'll register as one word, which doesn't help anybody. But for folders, that's very good. And for certain extensions, that's very good. Render materials is going to be, so if you're in here and you right click, we're going to go create. And this is material, I believe, which I can never find in here. Yeah. There it is. It's about halfway down, material, right under audio mixer. So what do we have here in this material? It's opaque. If you're trying to do transparent objects, don't select transparent, select fade. Then the color, and now it'll actually fade. Should. It's supposed to. Why is it not? That's weird. Sometimes this is a little finicky. What's in here? Albedo alpha? Oh, because I'm not linked yet. Anyway, let's put that on like 50% then. Or 175 is a pretty good number to test if it's opaque or not. And let's drag this guy onto the sphere. Let's try and drag that thing onto the sphere. Now you'll see its opaque change. Because it's not default anymore, it's referencing this material. So if you notice you go opaque, and it becomes entirely opaque, this slider didn't do anything. But if we keep it on fade, it'll become transparent. And if we put it on transparent, well, there's problems with this, just trust me. It comes in later, rendering other things inside of it and whatnot. Fade is best. Fade is favored. And then we can see it become nothing, and we can see it become more and more opaque. I'm actually going to leave it white, so this kind of looks like a little glass ball. That's kind of cool. What was you're going to play with the smoothness, or that's a metallic slider. Here's smoothness, which I like to do right about there. Yeah, 0.4 is good. I like to just shorten and type these in so they have shorter numbers once in a while, because sometimes they'll just let the float value run on forever, and that gets hard to calculate if you have to do your own adjustments later in certain things. But, so there's your custom material, there's your ball. You'll notice that if we hit play, it doesn't move. So, beautiful. Reason for that is this has no rigid body. So let's go to our sphere. We're just going to rename this player ball, actually. I do spend too much time renaming stuff, but you know, I've never lost my layer structure that way, which is very important. So with that, we're going to go ahead and add a rigid body. So we're just going to add it. It's a Unity component, so we can just go add component, rigid body, and our rigid body is a mass of 1. All right. So if you hit play right now, it would drop. It would run discrete collisions, which is less checking, continuous dynamic, adjust to be continuous with dynamic calculations, and speculative, I'm just going to leave it discrete, and because discrete will register as long as you don't exceed 25, 29 units per frame. Yes. So let's go ahead and run that. Or not run it, but we'll continue on with this. So this is the other part. Okay, this is a 3D game, but we're viewing it in a 2D way. And what we can do with this further is to make sure that our ball object, being a sphere, never catches the ground in a friction way that makes it go down the z-axis. So we have our y and our x that we view it on, and we never want it to move on the z. We want it to always stay 0. So for that, we can go and in the assets folder in our scripts, the z-axis lock, actually, so if we open that up, I'm actually going to rename this one because I don't want it to just do that. I want to represent the ball itself. So we'll just call this the ball script. Ball and ball script. Alright. And what I actually want to do is I want to go back and look at my document just to make sure we're on track. So we're going to go document view and view the document. So what's this document actually look like? Just looking here. So I want the ball to bounce, I want to limit the velocity, and that sort of thing. And then scoring, score more for successive broken blocks. That won't be necessary. That'll be an afterthought. That's why I put question marks after these things. They're afterthoughts. Fixes that make the game better but don't necessarily need to be done. And we have our persistent game object, and we have our reset to 0 on the scene number. We haven't done that yet, but we need to start scoring first. So it looks like bounce, limiting velocity, and then the blocks are what we need to work on. So if we pull back to Unity, go back to Unity. I don't know why it's compiling. There's nothing that it needed to compile. Okay. So if we're doing that there, what do we want to do here? So ball script, we're going to need a rigid body, and I'm not going to serialize that. What I'm going to do is I'm going to create a protected, because I might inherit from this and change it later. Protected, or not change it later, but inherit from and use it later. Protected, and it's going to be a rigid body. Industry standard is just lowercase r and b. And this is our variables. And then methods. So we're going to need to limit ball velocity. limit ball velocity, and it's going to be what, probably protected. I'm going to make it virtual. Nah, we can just leave it protected. For learning purposes, we can leave this empty, at least in that term. Protected void. Not throwing everything at the wall. That's for my other playlist. Limited ball velocity. That's a terrible autocomplete. Vector 3.0 is vector 3 that is all zeros, which means this would make it a velocity of 0 in every direction, which is bad. I did make an extension, but what do I want to do for this one? So rigid body doesn't assign on X, it kind of has to assign on that. So what we need to do is create a vector 3. So we're going to create a vector 3, and I'm going to call this H v3, meaning fold vector 3 equal to the rigid body velocity. Because it has some weird setting issues since it's a struct, I'm thinking is the reason, but it might be something else in Unity too. Actually, probably something with velocity itself that's different. But we're going to need another vector 3 that is n v3 is equal to a new vector 3, and let's just call it vector. Let's set that equal to vector 3, 0. No parameters. It's dot 0. So this is a actual struct of a vector 3 that has 0 for all 3 directions. All 3 values, I guess. It's not necessarily directional. And then nv3 dot x is equal to math f dot clamp. What? No. Just clamp. Which takes in a couple of methods or parameters. Takes in a couple parameters that are the minimum and so hold on. Yeah, this is velocity. Okay. Limit ball velocity. We never want the velocity to be higher than we want it to be between negative maximum, and let's call this our world velocity. So protected. And let's serialize this one just for practice. Serialize field protected floats, and that float is going to be Normally I would put this in something like a some type of parameter object, but since this is a very introductory one, we'll just put it up here. So negative little w. So negative world velocity to positive world velocity. And then instead of writing all these, I'm just going to go to the end of the line, hit Control D twice, and then edit these. So this is y, which means this is limit ball velocity. X and Y are usable. So Y, and then Z is 0, because I never want to move on the z-axis, so I'll just set it 0 here while it's running in physics. That's pretty good, ball script, so there's that. So this will limit the velocity, so it'll never, theoretically never move on the z-axis unless there's a big force that hits it and sends it flying before a frame, or before a second frame or something. So what do we want to do with that there? We'll probably open this one, which you'll probably see when that, similar to the one it auto-generates, which is update, when it creates a new script. We're going to use private, and unless I have something specifically that's going to continue through, I'm going to use private when I use update. And we're going to use fixed update here, actually. Because fixed update is when physics occurs. By default, it occurs 50 frames a second. So this code that we put in here will run 50 frames a second, and on the physics frame. So when you're changing things in physics, it's a good idea to do it in fixed update. There's other things that will, optimization things that don't necessarily go with that, but we'll use fixed update for this part because that would be the best option. For limiting the velocity in the frame. So we'll use that one. And limiting the ball velocity, so it's just going to take in its rigid body. And I need one more thing, because rigid body at this point still never gets set to anything that's real. It's a null value. So if we called it, we'd essentially be saying null.velocity, which is nothing. It's another null pointer. So we need an update method, not an update method. We need an, I like to use onEnable. Reason being, if you use netcode for game objects, it's best practice just to be in the hang of not using start or awake, because they tend to cause timing issues, at least when with the pattern I used. So private, and this is going to be on, and oh crap, and the panel's not open. Come on. There we go. So ball script, pretty basic. This was our limited velocity. And this was our private fixed update. And then onEnable on enable, which is rigid body, get components. Rigid body equals get component rigid body. Yes. Get component refers to game object, but is from game object class. And since this inherits from mono behavior, it knows to use lowercase game object. Which, as you can see, once I put the dot in here, it completes correctly, and it's basically the same thing. It's saying the object that this particular script is attached to as a component. Get component rigid body. So we don't need that part. All right. So now we have our rigid body declared up here. We have our serialized field that we'll set in here. Let's give it a default value, which we want to probably be about 25. And this is different than the max speed, which we could also set, or we could just modify using the world velocity, because the ball is the only thing moving in this instance, so we don't have to worry about a bunch of moving objects. Then we have on enable, we get the component that is the rigid body, private void update. We get the limited ball velocity, meaning we're just limiting the velocity of the ball by storing it, creating a new value, setting the new value, and then what we need to do is reassign it. So we need inside limit ball velocity, we need rb.velocity equals new value 3. So nb3. Save it up. And this is just because of the way physics works. I don't think it's anything else, because it just needs to be a complete new assignment for some reason. When I tried just setting it equal to itself.clamp or whatever, it really freaked out, so we're just going to leave that way. And there we are. So there's our limited ball velocity, so it can't pick up too much speed. And then we'll just flip back over to Unity. So back into Unity. What do we need with Unity now? We need to wait for compiling. Okay, then we can save. And then I'm going to put can ball script onto the player ball. And I drug it on, but what you should actually do is use add component. Ball script. And you'll notice that was set to 25, which is good. The maximum number being about 29, for reasons that by that time, if it's moving 29 units per frame, it's actually not registering collisions. That's the way physics works. It's too high for physics to react to, so you just need to limit it to under 29. If you're using defaults, again, you can set your own things, and then you might be able to use higher numbers, more accurate numbers, but for default, under 29. One more thing we need to do on the ball object is we're going to make a physics material. So in assets under materials, I'm going to create a new folder, which is a physics mat. And I used to think that physics materials weren't all that useful, but they are more optimized than that program that we just wrote to limit velocity, it actually costs more for me to call that infixed update and set the velocity than it does for the physics material to process in a frame. So if you have bounces or collisions where the knockback's a real big thing, you might want to consider using a physics object over something where you manually set the velocity or add force or something. It's a good tool for optimization. So we want to right click create, and physics material will be right down by GUI skin. So right click create and down by GUI skin. And we'll just call this ball phys mat. And ball phys mat has, if you look at the collider, that's where it'll go. It doesn't go in the rigid body. It goes in here. And I was thinking originally on having this ball be able to rotate, but I think what we're going to run into a problem there is that eventually it'll have force along its Z, X, or Y axis that we don't necessarily want because it won't be pointing the same way all the time. So I think we need to go into rigid body, and right here, freeze rotation. Another good one to do is we'll show you that later when we go back into code. Player ball. So in physics material, if we open that up in our inspector, we have dynamic friction. Not that big a deal. We have static friction, also not that big a deal. But bounce we can put on 1. And since we limited our velocity in the other one, we can't go exceed 25 across 2 frames. So it's actually like, what is it, 50 divided by 2, so I have 25 frames. It can't go more than 2 frames while being over 25 units per second-ish. And then bounce combine. Let's just use the max, because that's always guaranteed to beat this one unless the walls are set, but we're not going to set anything on the walls, so we're not worried about the walls. We just want the maximum bounce that we set for the physics ball. Friction combine, I'll leave the friction pretty much normal. And we do want it to gain a little bit of velocity, which is where we'll come up with some of the other stuff. We don't want it to bounce up and not reach for like 2-3 turns. We want it to be bouncing around immediately. So if we hit play on this currently, what do we get? We should get a bouncing ball that's limited in velocity that we probably won't see just yet, that it's limited yet. It's bouncing pretty good. It's gaining height, just slightly. I can't make it any more than 1, which is kind of sad, but I could always make a level so that like the ball didn't become tangible until it got right here, where the paddle would be able to hit it. Yeah. And you'll notice pretty soon it'll start hitting the top, and then we'll really get some bounce going, but it should be limited to 25 units per second for a velocity of 25 in any direction. And the reason we did a clamp is we want to clamp the value, but we don't necessarily want it to be... Or you could actually add a downforce too initially, which is what I think we will do. And you'll notice it's going up and it's getting kind of faster, but it's not exceeding physics world, or the world physics speed, which is cool. And game saving. So I think what we'll do is we'll just add a downward force after we get that rigid body, and that'll give us immediate bounce. And once we get an immediate bounce that we're happy with, we'll start looking at what else is on the dock. We'll start looking at limit velocity, stage design, minimum angle, scoring, if we have time, which it's almost 10 to now, so we probably won't have time. So we'll come back with paddle and scoring, and hopefully less stream interruptions with the next one. So let's go set that downward force. Switch it over to code, and I want a downward force. How do I create a downward force? So let's call it a downward start force, right? Let's do protected. Protected because I love to use inheritance. Protected void apply force. So if we're applying downward start force, then we want to open, pull it, save it. Yes, we're on the screen. Apply downward start force, and we're going to want rigid body. So RB dot, and like I said, I'm not. This is less performant than using a physics object, but at the same time, I'm not too concerned about it since I'm only running this one frame, and then I'm not doing it anymore. Add force. Add force, and add force needs direction. So do I want to type in a direction here, or do I want to create a variable? The answer is always variable. So serialized field, protected, vector 3. Yes, I do want vector 3, but I don't want it to be called position. I want it to be called start force. And the reason I want it to be called start force is, and the reason I want it to be a vector 3 is that I might not want to apply it straight down all the time. Maybe sometimes I want to start with an angle and then I'll lock. So start force is equal to, I'm not going to use vector 3, 0. That would be 0 force in any direction. I'm going to use vector 3 dot 1. Yeah, vector 3 dot 1. So it applies 1 force in any direction, which isn't really anything. But it'll show us that we didn't do it right if we didn't set it up correctly in the inspector. So we'll get to see that. Add force, we're going to go start force, and we're not going to multiply it by anything, so that's part of our check. And what we're going to do is add force, and we're going to use a force mode. Two parts, there's the direction, which also counts as the intensity, direction and intensity, and then we have force mode, which is how the force is applied. So force mode by default is always dot force. Dot force is a more consistent force placed on the object, but does actually stop applying to it. Whereas impulse is an impulsive force. Impulsive force, which in this case might actually be okay, because it's one-time impulsive force that's a bit higher on intensity. And yeah, sure, let's use that. So we're just adding that on start, and since we want to do that, make sure that's capital. Since we want to do that on start, since we don't have an on start method, I'm not going to use it because I get it on enable. The frame order goes awake, start, on enable. Essentially, these two don't always run in the exact same order, especially if you go to netcode for game objects. That aside, you can think of on enable coming after start, which is where we get our rigid bodies, so we don't really want to do that. So we're just going to do it on enable. And we're going to pull our apply start force. Apply start force. Because we don't need any parameters there, it's just pulled off our serialized objects, or structs in this case, up here. So that should all be set. That's the only thing we had to change. We had to create that method and put it in on enable. So that's all good. So then what do we want to do? Well, now we flip back to Unity and let's give it a test out. Let's see what it looks like. It's got to compile. Let me go play. And we should notice an impulse. Yep, it went off to the side a little bit. That wasn't a great one. Let's go into what we changed then. So that would be under ball, because it's in the ball script. And say I want to apply, well, that's part of the reason. This should be like, say I want to increase my intensity, go up to like -5 or something. That sounds good. So let's see what that runs us. Then you can just keep playing with this a little bit. Let's go -50 and see if it really kicks it at all, which is probably too high for impulse. Boom. You notice it started immediately and it's really too fast. So something that's probably like 25 is probably pretty good. -25. Let's zero out these because I just want it to drop down directly. And then we wait for it to compile, and it gives it a pretty good bounce right away. Might even go lower than that, but that's essentially what we can use for that. So what would we do for that? So now we have our ball. It gets an initial start speed going down. We have a frame that holds our ball and the rest of our game in place. So tomorrow we'll probably start looking at the paddle, or not tomorrow. Next one be Tuesday. So Tuesday the 19th. Tuesday 19th we'll be looking at making the paddle for the player to hit the ball up. We'll be looking at making the bricks to be broken, and we'll be looking at doing scoring and other things for that sort of kind of finish our core game loop up. Alright, hopefully less interruptions come on that day. Let's go ahead back and see our document, which might not be up. There we go. So yep, we got move, so we got physics material, strike through, we got use physics, strike through, we got limit velocity, strike through, stage design, we have to leave it, strike through, Minimum angle, we'll leave it. Score rules, successful blocks broken. We'll just do basic scoring for sure, but if there's time, we'll get into stuff like this. Singleton, which is actually one of the harder things. That's probably the hardest thing that'll be in this tutorial playlist here. As persistent game object, it is a persistent game object. We didn't quite do this one yet. We'll get to it. One thing that's not listed here, I don't like how that works. Huh. Is there something I can just put it under? Why is that way? Okay, I think it's double tab and bullet point, which is going to be not bricks broken, it's plan. The way we change rounds. So it's going to be in the scene, it's going to kind of be a singleton, not nearly as complicated as that. It's just going to make sure there's not more than one of it in the scene, and then carry on with its life. So that's round, let's call it tracker. Round tracker, and we're going to tab in, and it just needs to track that there are blocks in scene. Enable the canvas. When enable canvas when all blocks are destroyed, and it needs to be single. Meaning can't have more than one of them, which is going to be a lot easier than this one. But most of this is done. The input system is in, which might take a little while, but the big stuff's out of the way. So if you find this helpful, remember to like and subscribe. Comment any suggestions or ideas down in the comments. Don't forget to chill. And have a bug-free day.